The Blackjack AI project gives users a place where they can test their blackjack skills alongside AI. The main objective of this project is to provide an entertaining platform that encourages skill development in blackjack. It enhances the strategic thinking of players by giving them a sense of competition from a challenging AI opponent. The website aims to create a user-friendly environment where players can interact with AI and gain experience with betting cryptocurrency in a safe and secure space. The project also addresses the different skill levels of players by allowing them to adjust the intelligence levels of the bot that they are playing with. This ensures that players from varying blackjack backgrounds can benefit and grow from the Blackjack AI. The AI agent was developed by generating a Q table after training on 5 million games. Blockchain is used to maintain user balances and handle Cephalonia Ethereum deposits and withdrawals. In the front end, we use JavaScript and HTML that interacts with the Python backend and the Solidity smart contract. End users are anybody who wants to play Blackjack with the AI agents or just play in general.
Okay, and I'm going to lead us into the demo. When you connect to the website for the first time, you'll see you get a MetaMask pop-in prompting you to connect to the website itself. After you've connected once, you no longer have to connect again. The most you'll have to do is log in with your password. I can deposit and withdraw money here. So let's say I deposit in another 1,000 Wei. I can then confirm that amount, and my balance will update as soon as the transaction is finished. Likewise would happen with withdrawal, but for time I won't show that. The buttons will not let you do anything if you've added a total value. Let's say I wanted to deposit, or no, deposit would work. If I wanted to withdraw way more money than I have, I can try it, and as we've probably all seen and when we use Remix, the MetaMask will assume that the transaction will fail because of the fail-safes we have in the blockchain that do not allow you to withdraw that amount of money. In order to proceed, you must enter your name, or otherwise it will yell at you, and you can slide the level of the AI, which we will discuss how this works on the back end later. So I'll put it at 100. Then I proceed, and I'm in this screen. I can up my bet with the plus buttons here or the minus buttons. You cannot bet over your total balance, nor can you bet negatively. When you hit bet, the money will then be withdrawn from your account or withdrawn digitally from your account without taking any more of your way from your wallet balance itself, but all of what's stored in the blockchain. Once that updates, you can then deal your cards. I got a 15, and riskily I'm going to hit. I got a 17 now. I think I'll stand on that. Let's see, I stood on 17, the dealer busted, so I win. RAI also stood and the dealer busted, so it also wins. So I'll lock that balance in, and then once that transaction loads, we'll go back to the home screen to discuss another feature. You can exit here, and I'll put my name in again, and this time I'm going to upload an AI. So this is a custom agent that, in the case of right now, is just a small example of what one could create of an agent. So it's right here. It imports the base agent that we have that raises exceptions for everything that it's tried to do. And then this is the custom agent that would actually be used when imported, that right now is literally just returning S or H randomly. And that's all that it's doing for this demo. So I'll proceed now, and I'll bet myself again. And that agent file will always be tested upon submission to ensure that there are no more exceptions, there are no crashes. It will always be able to behave as expected, and that is validated before it is allowed to make it through to the screen. So now all of us will be dealt. I'll play. That puts me at about 17, so I'll stand on 17. I lost. The agent randomly decided to stand on 7. Obviously, it was just 50-50 shot of every time was it going to hit or stand. So it stood. I'll lock that change in, and that's about it for our demonstration. This is some of the testing now. So for the contract testing, we didn't really run any unit plans, but we do have this kind of testing document where I deployed a test version of the contract and just tested all of these things to ensure the contract behaved as expected. Obviously, accepting currency on deployment, being able to have money deposited from users if that change is actually reflected, One of the big ones is you can just request to change a balance as long as you have the owner's password or the owner's address. So making sure that you can't change your balance below zero and causing an integer overflow, and making sure that it actually validates that the owner's address was given, all of that stuff. And then at the bottom, just making sure that only the owner can evacuate all of the money out of the contract, which would return anybody's balance to them if they had a balance, and then returns the rest of the money to the owner. And these were all tested here, and any test that could be tested via an actual transaction is recorded in these transaction hashes that can also be seen on Etherscan. The final test I'm going to talk about is a way that we tested the back end without fully having to integrate it with the front end, where we were able to just test the game logic. So I'll enter my name up top, and then I'll press enter to begin. And so the dealer was dealt 2 cards. Really, in a real game, you'd only be able to see the face up. I was dealt a 10 and a 10, and our AI agent was dealt a 10 and a 7. So I'm going to stand here, and you can see I stood, the AI stood, the dealer hit once and was dealt a 10. So then you can see all kind of the same logic that was put through the front end, but without relying on an entirely working front end or blockchain integration. It was a way for us to just have to test the back end game. And I can just loop this for however much I want. I'll stand, I lost this time, etc.
To verify our model's performance over time, we plotted the results that it acquired after training on 5 million games. On the left, we can see that it maximized its reward over time, and on the right, we can see that the training error curve was flattened pretty dramatically as it went through training. On the bottom are some plots of its strategy that it created. We can see that without a usable ace, the bot became pretty conservative, knowing that it could easily go bust. And on the right, we can observe that with a usable ace, the bot was less conservative, knowing that it wasn't at risk of busting, as the ace could turn from an 11 into a 1 and reduce its total sum. We used an open source Q-learning algorithm as our AI model. Q-learning is a reinforcement learning algorithm where a model can learn and improve its strategy over time. The Q-table stores an action for each possible state of the environment. When a state is encountered, the corresponding action for that state is retrieved from the Q-table and executed, and its value is updated. The model chooses the action that provides the highest reward. We can see in the Q-table, shown here, that the left represents the state of the environment, and the right recommends the highest action that the agent can select. We also supported the ability to modify the smartness of the AI user, which modifies the probability of the AI user getting its decision from the defined behavior in the Q-table or making a decision at random. This is controlled by a slider on the main screen. And we can see in our function implementation that with probability 1 minus smartness, we return a random action, and with probability smartness, we choose from the Q-table.
As for our blockchain implementation, our smart contracts are written in Solidity and implemented in Remix IDE. We deployed our contracts on the Supply ETH testnet to run and host our contracts. Our smart contracts interact with the backend game code through JavaScript and Python files. As for our JavaScript code, it utilizes the MetaMask SDK provided by MetaMask to sign transactions with the user's account, while our backend code utilizes the Web3Py library and an Infura API key to connect to read-only functions that are implemented within our contract. For our AI and blockchain integration, the AI agent is connected to the backend game logic via Python. Our JavaScript code also sends post requests to our backend to request the next state of the game, including the states of the AI agents. The frontend also contains the main interface to the blockchain that our users will interact with. The AI and blockchain components more or less work in parallel alongside each other rather than completely dependent on each other.